Hello there. Welcome to Lolo Angel's vlog. Today, I will present to you how to graph the quadratic function in a short way. We will be using the magic number 135. Actually, this 135 numbers stand for the three slope. So this is M1, M2, M3. Okay. So let's say this is the vertex. Okay. So to use our our uh, M1, which is 1, meaning there is a denominator of 1. So this is rise if the value of A is positive, but go down when A is negative. And this is run. Okay. Our purpose here in using the slope is to just find out the points contained by the quadratic function. Okay, so if for example this is the vertex using a slope number 1 or m1, meaning you go up 1 and then run 1. Okay, so therefore that is our points. Okay, okay, if we will be going to draw, this is now the line. Okay, a straight line. But this is not the line or the graph that we wish to use. Okay, we only use that slope to just find out the next point. So actually, the sketch that we wish to do is a curve. So that's it. So this curve is a part of this graph. And then to find our next point, okay, we will be using our second slope, okay, which is 3, meaning that is 1, okay, rise over run. Okay, so 1, 1, 2, 3, okay, so there is the point. Okay, we go up 3 units and we run 1 unit. So this is our line. This is our line. Okay, which slope is Fm equals 3. Okay, but this is not the part of the graph that we will be using. It is a curve because this is a curve. So we will slowly, okay, it almost coinciding. I just want to show you that this line will not be used. We use only this line to find out the next point. And as it goes up, the line and the curve will be coinciding with each other. So I just want to explain here that it is not the line that we will be using when we are be going to use the slope. But these slopes will only be used to just find out the next point. Okay, siguro maliwanag yon. I hope it is clear. Okay, so let us do this one. Let us do this one. So the first step that we are going to do is to find first the vertex. So the vertex is 3, negative 4. Okay? And then we will plot this vertex at the coordinate plane. So it is somewhere here. Okay? So that is our vertex, which is 3, negative 4. And again, using that idea that we wish to find the next point after the vertex, and we will be using the magic number 1. Okay, so we will rise. We will go up simply because the value of A is positive. So that is, okay, 1. Okay, so therefore, the next point is here. Okay, so that is our P1. Okay. And then, to, to find the next point, let us use the, the the slope 3. Okay, meaning 3 over 1. This is rise, this is run. Okay, so as I have illustrated here earlier, not the line that we will be going to consider, but the curve formed by these 2 points. So the next point that we want to have is the 1, 2, 3, and then run 1. Okay. And the next slope, which is slope number 3, is 5 over 1. Okay. So 5, 1, 2, 3, 4, 5, run 1. Okay. So in this part, the curve and the line is almost coinciding with each other. Okay. So, okay. Let us connect all the points to sketch the curve. So this is now our curve. Okay. So here we can uh, clearly determine the difference between the line and the curve. But somewhere here, it is almost coinciding. But the most important thing, as I have told you, is to just find the next point. But the idea of using 135 is simply that is a slope of the line that will guide us to just determine the points contained by the curve or by the quadratic function. Okay, but not the line that we will be using, not the line, but the curve that we will be using because that curve is contained by that function. Okay, after having the half of the parabola, you are going to to draw the axis of symmetry. If our first coordinate is 3, therefore, the axis of symmetry is the line x equals 3. Okay, so let us draw that. Okay, so this is now x equals 3. Okay, by using the axis of symmetry, we can easily determine its symmetrical points because the axis of symmetry divides the parabola into two equal parts. And so therefore, we need to find the symmetrical point of P1. And since P1 is 1 unit away from the axis of symmetry, therefore its symmetrical point is also 1 unit away from that point. If this is 2 units away from the axis of symmetry, therefore its reflection is also 2 units away from that axis of symmetry the same way. So therefore, here is our another point. So therefore, we can now connect all the points to sketch the curve. Okay? Okay. So we will extend by using arrow because meaning the parabola will continue to go up. Okay. So that's it. Okay. Always remember that when A is 1, okay, if the value of A is positive 1, use 135. If A if A is negative 1, okay, so our M will be 1 times negative 1, 3 times negative 1, okay, and then 5 times negative 1. Okay, so therefore, uh, our slope to use is -1, -3, and -5. Okay. If A is negative, the parabola goes downward. Okay. If our A is 2, okay, so our slope 1, slope 2, slope 3. So this is 1, 3, 5. Okay, just multiply the slope by 2, 2, 2. Okay, therefore, the numbers that we will be using to trace or to find other points are 3, okay, no, 2, 6, and 10. If this is, if A is, okay, sorry, if A is 2, okay, correction. If A is 2, ito yung gagamitin. And if A is 1 half, syempre, of course, you are going to multiply the 135 by 1 half. That's it. Okay. So that is the easiest way to find the points contained by the parabola. Okay. I hope you like our video today. Okay. Thank you once again, and God bless you all. Don't forget to subscribe and hit the notification bell so that you will always be updated with all the videos that I will be going to upload. Thank you very much.